Hello students, today we are going to learn another important topic of calculus, which is differentiation. We have already encountered this topic in 11th standard and we know lots of basic formulas. Let us understand differentiation first. Okay, again, like continuity and differentiability, we will start it with geometrical interpretation. Okay, and then we will derive a formula. We already know the formula, but let us see how it goes. So see, in continuity we found out that the function is continuous without any break, and in differentiability we found out that how smooth the curve is, means how the changes are happening. Now differentiation, see, whenever we hear about calculus, two important things comes to mind, right? One is differentiation, another is integration. Okay, what is differentiation? Differentiation is basically to find out the smallest change in anything, right? We know the big change, now we want to know the smallest change, smallest ever change we can find out. That is known as differentiation. Okay, and integration is that if we know the small part of anything, how to find the large part of that, that is called as integration. So basically, if you talk in layman terms, differentiation is basically the subtraction part. By subtraction we get smaller things, so differentiation is similar to subtraction and integration is similar to addition. Okay, but not actually subtraction and addition, it is something different, and we will find out the formula for that. So if you draw a graph, right, plot a graph, suppose like this is continuous, this is differentiable, and now we want to find basically what, that how the changes are happening, okay, at certain point, right? See, changes are happening everywhere. If you talk about from this point to this point, okay, the curve is moving down. If you talk about from this point to this point, the curve has started moving up. Okay, and suppose at these 2 points the curve has started taking a sharp turn vertically, right? Now, so there are changes at every point, and we are basically concerned about changes at a certain point. Suppose at this point, okay, this is my x-axis. So at this point, what are the changes associated with that curve? We are interested in that thing. Okay, suppose if you take these 2 points, right, this points belongs to here, which is x1, and this point belongs to here, which is x2, correct? Now this, with respect to this x1, we have a point called y1, or you can write f of x1. Okay, similarly for this point we have y2, or f of x2. Okay, so we want to know what is the change which has happened here. So basically, for a change we write a formula like this: y2 minus y1 upon x2 minus x1 means change in y with respect to x. If we are changing our x, my y is also changing, and how that changes are happening, we want to know how fast, how slow that change is happening. Okay, so basically this y2 minus y1 upon x2 minus x1 is the formula for finding the change, right, with respect to x-axis or with respect to anything. Whatever there is in the denominator, we are trying to find out the change of numerator part with respect to denominator part, right? So your x and y are basically defining the things that you are going to find out. Okay, so we are going to find out the change in y with respect to x. Now if you talk about in coordinate geometry, what is this? This is basically a formula for a slope of a line, correct? Slope of a line. So basically we are finding a slope of tangent. So there are different names given to this differentiation. Sometimes it is called as slope of a tangent, sometimes it is called as rate of change, right? So lots of things will come, but all of things are actually same thing, which is what? Change in one quantity with respect to change in another quantity. Okay, your speed is also one of the same thing. Speed is what? Change in distance upon change in time. So when you are saying that the distance is changing with respect to time, this term is known as speed. So speed is another form of differentiation only. Okay, so now when this point, so now we know the formula y2 minus y1 upon x2 minus x1. This is the formula of differentiation. Now let us elaborate this. Since we are interested in the small changes, so what I will do, I will make this point very close to this x1. Okay, so close that my x2 is basically what? x1 plus h, correct? So when x2 is x1 plus h, my y2 will be what? It will be like, so the formula for differentiation will be changed as f y2 is what? x2. So basically fx2 minus fx1 upon x2 minus x1. Okay, I have written y2 and y1 in form of fx1 and fx2. So it will be like f of x1 plus h minus f of x1 upon x1 plus h minus x1, and this h is very small, right? So you can cancel x1 here, only h will be left there. So basically for differentiation, this is my formula. What is this? F x1 plus h minus fx1 upon h, correct? And the change, this change, basically you're talking about the numerator, change in numerator. So y2 minus y1 upon x2 minus x1. This is known as delta y upon delta x. This delta is basically sign, okay, which represents difference. Okay, delta is the sign which represents difference, and when this difference is very very small, right, very very small, so we just replace this delta by small d. Okay, when the difference is very very small, almost close to 0, then we just we replace this delta by d, and then this becomes dy by dx. Okay, so differentiation is popularly seen as this, in this form, dy by dx. So the whole thing is same. We call it y2 minus y1 upon x2 minus x1, or fx1 plus h minus fx1 upon h, or del y upon del x and dy upon dx. All these things are representing same thing. Okay, so there are different presentation there to show the differentiation part. This is also known as my derivative. Okay, basically what, if you go in my differentiability video, then you will find out that this formula is basically right hand differentiability or derivative. This is RHD. Since so then the question will come, why not LHD? See, we have already proved this. All things are for continuous and differentiable function. We have already proved that my RHD is equal to LHD. So either you find out RHD or you find out LHD, nothing matters. So basically what we are doing, we are finding out RHD. Okay, because we are very much familiar or very much you say comfortable with the positive signs, right? So that's why we we are taking only RHD. So this is the formula for differentiation and the geometrical meaning of differentiation. Okay, so our first topic in differentiation after the introduction is differentiation by first principle. We have already defined our differentiation part, which was what? dy by dx is equal to limit h tends to 0. This is similar to our right hand derivative, correct? So whenever we find differentiation using this formula, okay, we call it differentiation by first principle, right? Because this was the first rule, first principle, or first definition of differentiation, right? So there are lots of formulas using this formula only, okay, but we will see how those formulas have come. I'll show you some of those formulas, how to derive that, and then you will practice for other sums also, okay? So let us take our first formula. Okay, one more thing I want to say here, that this is also known as, okay, f dash x, right? This dy by dx, or the derivative part, the differentiation part, this is also represented by f dash x, right? So let us take this fx as sin x. On 11th standard we already know that if you differentiate this, we have cos x, right? Differentiation of sin x is what? Cos x. Let us find out whether it is coming using the first principle or not. Okay, so f dash x will be equal to, if you apply that formula, it will be sin x plus h minus sin x upon h, limit h tends to 0. Now we will use the formula sin c minus sin d, which is 2 sin c minus d by 2 cos c plus d by 2. Right? Here your x and x will be cancelled. So, and now what I will do, this 2 will, I will put 2 below this h. So it will be like limit h tends to 0 sin h by 2 upon h by 2 and that cos part. Right? It is basically what? X plus x, 2x, 2x plus h by 2. So if 2 of x will get cancelled by this, so x plus h by 2 will be there. Right? Now we know the limit formula here. Sin h by h, sin x by x is what? 1. And if we put h is equal to 0 here, only x will be there. So it will get you cos x. Right? So using this formula, we have finally found out that this, how this differentiation has come here. Okay, let us take another example. My first principle, I have taken this fx is equal to x raised to minus 3 by 4. So let us write here, my differentiation will be what? Limit right, this is my formula for first principle. Let us apply it here. So it will be like limit h tends to 0. What is fx plus h? It will be x plus h raised to minus 3 by 4 minus x raised to h. Correct? Now the power is in negative, so let's make it first positive. So it will be like 1 upon x plus h 3 by 4 minus 1 upon right, taking LCM and simplifying it, it will be like x raised to 3 by 4 minus Correct. Now how to do this? First of all, we will use the rationalization method. Okay, it will be like x raised to 3 by 4 plus so the numerator will become in the form of a square minus b square, which will give you x raised to 3 by 2 minus x plus h raised to 3 by 2, and denominator will be like h correct. Now if again we rationalize it, right, so our numerator will become and denominator will be like right. Now what we will do, we will expand this x plus h the whole cube formula. So what I am doing here is correct. So your x cube will get cancelled, and if you see here, your h can get cancelled from each of this h. So if you take h common from here, this h will be cancelled. It will be like square here. This will be cancelled. This will be cancelled. So in the next step, what we can write is minus h square minus 3x square minus 3xh, and in denominator we have x plus h. Now we can put our h as 0. Why? Because there is nothing that will make denominator as 0. So if we put h is equal to 0, this will become 0, this will become 0. So only numerator will be left as 3x square minus 3x square, and in the denominator it will become x raised to 3 by 4 because h will be 0. Then x raised to 3 by 4 again. Similarly in this bracket, x raised to 3 by 4 plus x raised to 3 by 4. Here it will be x raised to 3 by 2 plus x raised to 3 by 2. Now we need to just simplify with x. So it is minus 3x square upon x raised to 3 by 4, x raised to 3 by 4. The power will get add up. It will be x raised to 3 by 2. Here the two terms are there, so we can write 2x raised to 3 by 4. Here also two terms are there, same, so 2x raised to 3 by 2. Again simplifying it further, this x raised to 3 by 2, x raised to 3 by 2 will give you x raised to 3. So minus 3, and this 2 and 2 will become 4. So we can separate this number minus 3 by 4 and then we can write x raised to, and using the power exponential form and the law of exponential, it will be like, here it is 2, this and this will become 3, so minus 3 and minus 3 by 4, right? So you will get your answer as minus 3 by 4. 2 minus 3 is minus 1, and then when you simplify you will get x raised to minus 7 by 4. This is my final answer, right? So this is how you differentiate using the first principle method. Okay, let us revise our basic differentiation formulas, which is the first one was differentiation of x raised to n is equal to what? N x raised to n minus 1. N will be any number. It can be a integer, it can be a fraction, anything, right? Now then differentiation of a raised to x. A will be what? Basically condition here is a should be greater than 0, right? So a raised to x log ea, and the specific formula for the specific condition or specific case, you can say when a is equal to e, this will become e raised to x. Why? Because log e will be equal to what? 1. So if you write it here, log e is equal to 1. That's why only e raised to x. Similarly, we have log, differentiation of log x is basically 1 upon x log ea, and one special case where this a is equal to e, then we can, this is only 1 by x. Again the same logic, because log ee is equal to 1, right? So these are the three related with what? Your polynomial, your exponential, your logarithmic function. Now and we also know the trigonometric formulas also. Sine, we already know sine is what? Cos x. Differentiation of sine x is cos x, differentiation of cos x is minus sine x, tan x square x, cot cos minus cos x square x, sec is sec x tan x, and cosec is minus cos x cot x. So you need to remember these basic formula while differentiating other things. Okay. Now let us look at the basic algebra of differentiation. Okay. First of all, we should remember this thing, that differentiation of any constant function means any number is equal to 0, right? Without any variable, it is 0. Now the first algebra is like, if there is a multiplication of a constant function and a function of x, then that constant function can be taken out of the derivative part and we can simply differentiate the effects. Okay. Next, suppose there are two functions, one is fx, one is gx, and either their sum or difference is given, and we need to find the differentiation of those two functions. So we can find the differentiation individually and then do the sum and difference later on. Okay. The third one is basically known as my product rule, UV rule. Right? It was like you can take one function outside, differentiate the other function, and then next time first function will be out, differentiate the second one. Right? And in between those two differentiation there is a plus sign. Next, u by v rule or quotient rule. So what is this? Quotient rule is like, again, the denominator part, the gx will be outside first, then differentiation of fx upon dx, then this minus fx d by dx of gx, and another term is added here, divided by gx whole square. So you need to remember these four formula for differentiation.